right, hey guys. Hi. We're going to be going through a few little details here that we did in class today that are new from I should say Monday's lessons. So I'm going to go ahead and get rid of my ugly mug. Peace. Bye, ugly mug. And we'll go ahead and start. I'm going to just hit on the key points. Um, so first off, want to do a quick review on this type of a problem because these are going to come up again. These word problems that we did last semester. Okay, so this particular one says John's Butcher Shop has a processing fee of $40. If you want some of your meat made into deer jerky, they charge $5 per pound. Okay, we want to write a linear equation that gives the cost C for any number of pounds P of deer jerky. So remember, we're writing an equation in slope-intercept form. We are writing y equals mx plus b. Now, we're not going to use y and x. We're going to use c and p instead. Okay, but we can figure out what is our m, what is our rate of change, our slope, and what is our b, our y-intercept, our starting cost. And remember, there's a key word that we look for. Okay, we only have two numbers here. The key word that is found is the word per. The word per helps us see that this 5 is actually our slope. So I know my slope I have is 5. My rate of change is $5 per pound. And then our starting cost is that $40 processing fee. So that's the y-intercept. Okay? So I would have C equals, let me write over here, C equals 5P plus 40. Now, the graphing we talked about, making sure you pay attention to scale. Okay, so y-intercept's 40, and my slope is 5. Remember, 5 over 1, up 5, right 1. But here's the trick. If I go 5 lines, this is by tens on the y. So that's not going to work out. I have to go up 5. So up 5 from 40 is to 45, right 1. So that's where that next point would be. Up 5 would be 50 over 1. Up 5 would be 55 over 1. Up 5 would be 60 over 1. So that's what the line generally looks like. The last part is being able to answer questions using our equation. It says determine the cost if you purchase 14 pounds of deer jerky. So I got to figure out, is this 14, is it a cost or is it a number of pounds? And it says it is a number of pounds. So this 14 goes in for the P. So I have C equals 5 times 14 plus 40. 5 times 14 is 70. And 70 plus 14 is $110 bills, y'all. Okay. So again, these are going to keep coming up, especially the writing of the equations, especially being able to plug things in. Okay. Now, our new information. And when we're back in class, I will give you a note sheet that has some of this beginning information on it. Okay. But there is some key terminology that shows up on these types of problems. Okay, we are talking right now about systems of equations, and that's what we worked on Monday. Okay, but I just gave you the nuts and bolts and the basics. Now, a system of equations is two or more equations at once. Okay, with two or more variables. Okay, now in Algebra 1, we typically deal with two equations and two variables. Okay, we don't usually deal with more than that. Okay, but you could have more. Now, within the systems of equations, there's some terminology that shows up. Okay, and this stuff talks about how many solutions there are. We have consistent, okay, and we have inconsistent. These two are the main two categories. Consistent basically means it has a solution. Inconsistent means it does not have a solution. And then within consistent, there are two types. There are independent and dependent systems. Okay, so let's look at what they do look like. Okay, and you will have this particular slide to use. Okay, as your notes. Okay, so The most common one that we're going to see is that there's exactly one solution. And if there's one solution, okay, our terminology wise, okay, we would say that the system is consistent and independent. It's consistent, it has a solution. It's independent, okay? There's just one, okay? And then remember, we talked on Monday when you put the two lines on the graph, this intersection point ends up being the solution. Yes, you do need to name it, okay, correctly. The x would be 2. The x would be 2 on this one, 1, 2, 3. The y would be 4. So we would say that's 2, 4. Okay? The next type that has a solution is consistent is there's infinitely many. Okay? Infinitely many. And that is consistent and dependent. Okay? There's infinitely many solutions. They're all on this particular line. Okay? They're all on that line right there. Now, what Mr. Alone likes to do, okay, on the graph, it'll typically just look like this with one blue line. I like to draw a second set of arrows just to remind myself that I really did put two lines on this graph. There's just the same thing, one over top of the other. So they're always touching each other. There's infinitely many solutions. Okay, your answer for this one would be infinitely many. Okay, and then we have no solution. That is, terminology-wise, that is an inconsistent solution. Okay. Now, when you see these, you're going to notice that they start in different places, but the slopes look the same. Okay, they're parallel lines. Okay, and our answer for this would be no solution. Okay, now let's look at a few of these so that we can see some little nuances between all this. So, here's the set of graphs. We decide, is this consistent independent, consistent dependent, or inconsistent? So the first thing I look at is, on my graph, do these lines cross ever? Okay, and they're parallel lines. So no, they're not going to cross. So this is going to be no solution as an answer. And this would be an inconsistent system. Okay, because the answer is no solution. Now, what I want you to notice is with an inconsistent system, I want you to notice that both of the slopes are the same. Both of the slopes are -1. Okay, but their starting points, okay, the y-intercepts are different. And that should happen every time. So if I'm going to answer that something is no solution, if I'm going to say it's an inconsistent system, they better have the same slopes and different starting points. Okay, that's got to happen. Okay. The next one we want to look at, this is the most common. Is it consistent independent, consistent dependent, or inconsistent? And we see that these cross right here. Okay, so it has one solution. Okay, this would be consistent independent. Consistent independent. Now the actual solution would be 2, 1. Okay, now what I want you to notice on this one, and this should happen every time, notice that our slopes are different. Okay, this one, the slope is -1. This one, the slope is +1. If I have different slopes, they will cross somewhere inside of this graph. And if I'm having to do it by hand, I promise you it's going to be in a perfect spot. Okay, I'm not trying to trick you. I'm not trying to go on a test. This is what it looks like. I'm not trying to put a problem on a test that looks like this. That we know obviously is going to intersect somewhere out here, but when we're taking the test, they don't intersect on our graph. I promise you it's going to intersect on the graph. If you're seeing something like this, more than likely you made a mistake with slope because they're supposed to intersect on the graph somewhere. Okay, so that's consistent independent, has one solution. Okay, the last type, notice there's only one line on the graph, but there's actually two equations. Okay, there's actually two equations. Well, this particular one is going to be consistent dependent. Okay, the lines are one on top of the other. The answer, remember, is infinitely many. Okay, And these are actually the exact same slope-intercept form. If I solve this second one, I'm going to get y equals 2x plus 3 in slope-intercept form. So notice they have the exact same equation in slope-intercept form. Okay, and that's why they're one on top of the other, but it's infinitely many. And so those are the three basic types. Okay, now just so we can see it, I want to go over one problem because you're going to be doing these on Alex. So remember, you graph these individually. So for this first one, y-intercept's 9. So I plot that point, 9 on the y. My slope is the 4/3. Remember, it's positive, so I'm supposed to go up and right from this spot. But this don't fit. I can't go up 4, right 3. It's off of my graph. So I've got to reverse it. I've got to go down and left then. So from here, down 4, 1, 2, 3, 4, left 3. And I keep doing that. You have to make extra points. Down 4, left 3. Down 4, left 3. So one of those 4 data points are going to be the solution. And I'll go ahead and connect them. The second one I'm going to put in blue. I have a y-intercept of -5. So down 5, put my point. And my slope here is -1. So -1 over 1. It's negative, so that goes down and right. So down 1, right 1. Down 1, right 1. That's going further away from this red line, and I want to see where they intersect. So I'm going to reverse this. Up 1, left 1. Up 1, left 1. Up 1, left 1. Up 1, left 1. And I see that they're going to cross right there. So let me draw my graph, draw my line. And then I have to name that point correctly. Okay, this would be consistent independent if I'm looking at the terminology, but I got to name this data point. On the x, it is -6. On the y, it is +1. And that would be my solution. Okay. You are going to be doing these problems on Alex today. Okay. We're not going over every single one of these today. Okay, you're going to be doing these on Alex. Okay. Reminder that you need to look on our Canvas page under resources, and you can find your information for Alex. If you're struggling to find that, okay, shoot me an email. I will help you get it. Okay, but it is there. All you got to do is click on resources on our Canvas page, homepage. There's a tab for like the Alex website, and then there's a link that has everybody's usernames and passwords. Okay, so you can get into Alex, you can get the assignment. The assignment that we are working on is the one that says Graph Systems of Equations. Okay, there is a help video linked to the assignment. Okay, so make sure you click on that video if you are unsure how to actually put the information on Alex. It's only a quick 2-3 minute video, so it won't take you long, and it is helpful. On that particular assignment, what's required is that you do numbers 1 to 16. 17 and 18 are extra problems, okay? But 1 to 16 is what you need to get done, okay? Have a great day, and we will see you later. Adios.